Take a look at when and where to use a protecting group, but before we do that, let's talk about how to use it in the first place, how to use it. So, what the protecting group reacts with, first of all, is very important. The protecting group can only protect two things. Ketones, meaning carbonyls, where the only things attached to that C double bond O are other carbons, and aldehydes, where the only thing attached to that carbon is hydrogens or carbons. Things like esters and amides and all that other fun stuff, carboxylic acids and the work. So any carboxylic acid derivative, I guess I could say, any of these guys, so on and so forth, cannot be protected. It only works if this carbonyl carbon has only the double bond O. Okay? So let's look at how we add it now. What you're going to do is you're going to have, say, your ketone. Over your arrow, if you want to add the protecting group, you're going to have these earmuff looking things, or diol. And then you'll also have H+. Now the way you can think about how to add this is redraw this thing on the product side. Now what you're going to do is you're going to draw your earmuffs next to the oxygen, kind of like a hat. Okay? Now you're going to erase the double bond O and the oxygen and its double bond. You're going to erase the hydrogen off of each of those OHs, and now connect each of those oxygens to the carbon where the double bond O used to be. And there's orgobase. Your carbon is now protected. How do we remove the protecting group? To remove the protecting group, to go from this to this, you will use H3O positive. Now, how do we figure out what the structure looked like before we protected it? Well, once again, what you can do is take the thing that's protected and redraw it exactly the same. Now what you want to do is, you want to find the carbon that shares the two oxygen bonds, that has two separate single bonded oxygens to it. So that's this carbon right here. One single bond to an OR group, one single bond to another OR group. And what you're going to do is you're going to erase each of those single bonds that connect the carbon to those oxygens. The two oxygens that are drawn in right now, you're going to make OHs. So just put a hydrogen on each of them. And then on the carbon to where they used to be connected, you will draw a double bond O. And so that's how you can remove the protecting group if you have trouble visualizing it. Now let's talk about where and when to use it. So the most likely reason you have to use a protecting group is because in your synthesis you have a structure that has more than one oxygen-based species a decent distance away from another oxygen-based species. For example, this. When we broke open the hemiacetal, we now have a carbon with an OH and a carbon with a carbonyl. And we'll find that if we just start trying to cut carbons apart, we're going to run into issues. Let's look at this. If I wanted to cut these carbons apart using the rules we set up so far, well, we know we cut using an OH, so we have carbon A, we have carbon B being the single bond away from the carbon with the OH. And now I want to say over the arrow, step 2, H+, and I want to redraw this, OH, double bond O, and I'm erasing the bond between A and B. I'm turning the OH into a double bond O, and I'm putting a lithium on the carbon that was attached, or that didn't have the OH. Now notice something. We said that lithium puts a negative charge on a carbon, and that carbon loves to attack carbonyls. Well, it could easily attack this carbonyl, but notice the problem. There are now two different carbonyls that carbon minus that is produced by the Li can attack. It could attack this one, or it could attack itself. And this is the reason why you need to use a protecting group. Because this negative can very easily attack itself, and you would never end up getting this. That's how you know you need to use a protecting group. If you ever see a structure that you need to cut apart that has multiple oxygen-based species, be it OHs, carbonyls, or carboxylic acid derivatives, first protect a carbonyl. So if I'm going to do the synthesis, my next step before I cut is I need to put a protecting group on. Now notice the direction of my arrow. I'm ending at a C double bond O. And we saw when I was drawing over here, the arrow that ends at the C double bond O is the reaction that removes the protecting group, because we're going backwards, right? So I need H3O positive over this arrow. I'm removing the protecting group, but since I'm going backwards, that's basically me putting the protecting group on. So this OH doesn't get touched. We use a different marker. This one's done. That one's not good either. Come on, there's got to be one marker with juice in it. Nope. Where'd my good marker go? There you go. Okay. All right, so this OH is untouched because OHs don't react with the protecting group. I have the carbon chain being the same. And now here's my carbonyl. I'm going to draw my earmuffs next to it. I'm going to erase the double bond O. I'm going to connect both of those oxygens to this carbon by a single bond and erase the hydrogens. And now this carbon is protected. Ortho-base is blocking it from interacting with any of my cutting reagents. So now I'm free to cut as I wanted. So once again, I'm going to do that A-B trick. So I have carbon A, I have carbon B. I'm going to redraw everything exactly the same over the arrow, step 2, H+. And now I have here we go. Okay, so I redraw everything exactly the same. So here's carbon A, carbon B, the rest of the carbons, and then the carbon that got protected. So I have this. And now I'm going to erase the bond between A and B. I'm going to erase the hydrogen, make this a double bond O, and put a lithium on the carbon that didn't have the double bond O. So this is 4 carbons or less. I'm done with that. But what about this? This is 1, 2, 3, 4, 5, 6. You can't forget the protecting group has 2 carbons in it. So I need to remove the protecting group. But can I remove the protecting group right now? This is another really important rule to know. If I were to do in my next step the H+ step to remove the protecting group, or technically going forward, add it, there's a very important thing to point out. Notice what I have when I remove that protecting group. I go back to this, and there's lithium over here. I'm right back at that problem I talked about. I can't have a carbon with a lithium on the same carbon chain as a carbonyl, unless I want to form a ring, which I clearly don't. Also, another point to make is we said before lithium makes this carbon negative. Carbon negatives are very, very strong bases. We're reacting with H+, which means this wouldn't even form the ring. This would just grab this proton and then nothing would happen. You'd still get protected, but now the lithium's gone, but we need that lithium if we want to do this step here. So you can't remove the protecting group yet. You have to get rid of the lithium. So there's one more step you have to do first. What adds a lithium? Li over the arrow. All these markers are dying on me. Li over the arrow. And that turns the lithium back into a bromine. Bromine doesn't have any of these issues that we were just talking about, which means now I am free to remove my protecting group. So over my arrow, since I'm going forward, I'm pointing at the protecting group, which means this step is the step that added the protecting group going forward. So I draw my earmuffs, my H+, and now I have my bromine, my carbons, and this is the carbon that had the 2 single bonded O's on it, which means that is the carbon that should now have my double bond O. And now I'm done because I have 1, 2, 3, 4 carbons or less, and that's how you would synthesize the semi-active tau.